Alrighty, so this little mini lesson is going to go over what are known as unit vectors. So as we can see on the screen here, unit vectors are vectors that have a magnitude of 1. Because we know all vectors have both a magnitude and a direction. If their magnitude is 1, that means their biggest purpose is direction. So we often use unit vectors to describe the direction of a specific vector. Some of the most common unit vectors that we're going to see, especially in this unit, is I. Anytime we see a little I, um, a lot of times I'll have this little hat on it. I call this I hat sometimes. I think in many textbooks, especially math textbooks, they might just bold it. But anytime you see I in component form, it's 1, 0. So it's only going in the x direction. So I is a very specific unit vector that talks about the x direction. J, similar thing. If it has the hat on it, we know it's a unit vector. Some places just bold it to say that it's a vector. But whenever we see J, we know that this is its component form. It only has direction in the y direction. So these are some common unit vectors. But the unit vectors don't just have to be in the x direction or the y direction. They can be in any direction. And so what we can often do is we can try and take any vector that we've been given and find its unit vector. So this is just telling us what direction is this vector going in. The way that we do this, once again, you can see that I have the hats on here to say that we're talking about finding the unit vector. To find the unit vector, you take your vector and divide it by itself. That's because we know anything divided by itself is equal to 1. So here, we're going to take the original vector and we're going to divide it by the magnitude of the vector. It's written this way as well to show you that dividing is really the same thing as multiplying by 1 over. On the last few slides, we saw that whenever we're multiplying by something or dividing, we're going to take those component forms. So if we had C here, we're going to distribute that in. So that's what we're going to be doing here. We're going to find the magnitude, and then whatever that magnitude is, we're going to divide both of the components by it. So let's give this a practice. So here, we're going to find the unit vector for these two specific vectors. So O hat would be the unit vector. It's going to be equal to O divided by the magnitude of O. So I'm going to first find the magnitude, which we know the magnitude is equal to the square root of the components squared and summed. So negative 2 squared is 4, 5 squared is 25. This gives me the square root of 29. So to find the unit vector for O, we're going to take negative 2 and divide it by the square root of 29. We're also going to take 5 and divide it by the square root of 29. I'm going to make that a better bracket there. And that's it. That's finding a unit vector. It's easy. It's finding the magnitude and then dividing your two components by the magnitude. Some of the things that you'll be asked to do is to prove that this has a magnitude of 1, that it is a unit vector, which we can do once again just by doing what we did earlier. So the square root of negative 2 over the square root of 29 squared plus 5 over the square root of 29 squared. When we square these, we're going to get negative 4. No, we're not. Sorry. We're going to get positive 4 over 29 plus 25 over 29. If we do that, we get the square root of 29 over 29, which is equal to the square root of 1, which is equal to 1. Once again, all this is doing here is proving that this vector has a magnitude of 1, so therefore it is a unit vector. We can do this again here. We've seen the 3, 4, 1 often. So the first thing I'm going to do is I'm going to find the magnitude. It's going to give me 9 plus 16, which is 25. The square root of 25 is 5. Some of you may have noticed immediately this is a 3, 4. Our components are really our x and our y, so it was a 3, 4, 5 triangle. So some of you guys may have made that jump. Either way, to find our unit vector, which once again, I'm going to keep using the hat to just show that it's unit vector. Once again, I think in your textbooks, they might just bold this, or sometimes they'll just call it U. just say unit vector, make sure that you're checking those different types of notations. So the unit vector then is going to be 3/5, 4/5. So we've now demonstrated how for any original vector you've been given, you can create a unit vector. Once again, the unit vector simply has a magnitude of 1. If we were to do this out, we'd also get down to a magnitude of 1. And because it has a magnitude of 1, it's showing that it's in the same direction. If I were to plot both of these, they would be in the same direction. This one would simply be longer. Its magnitude is 5. This one only has a magnitude of 1. So as I said at the very beginning, if you go back, there's some really common unit vectors. I and j are the most useful ones. Because of I and j, we actually can rewrite vectors in what's known as writing them in a linear combination of vectors. Whew, that seems like a scary combination, but this is actually relatively simple. Whenever you see this, what it's asking you to do is to write it in what I honestly just call IJK notation. I threw in K there. K is in the z direction. So if you are doing three-dimensional vectors, then you would see K as well. At our level, we're not going to be doing that. So here, what we can do with this is we can rewrite our component forms by saying the x component is going to be multiplied by I, and the j or the y component is going to be multiplied by j. That's because we're just going to take a scalar and then multiply it by I, which means it's going to be going in the x direction. We're going to take a scalar and multiply it by j, which means it's going in the y direction. So I have that kind of written out here, what that really looks like for you. We can see that if we have a vector, x, and we write it in component form with the little brackets, vx, vy, then we can rewrite it as vx times I plus vy times j. So here's my example. This is a vector we've seen a lot. -2, 5 can simply be written as -2i plus 5j. So these are just the same thing. Once again, 3, 4 could be written as 3i plus 4j. Once again, some people just bold these if they don't have the hats, but you ever see an I and a J, that means we're writing it as a linear combination. These are equivalent. You can go in the opposite direction as well. Say that I gave you 10I minus 6j, then we can know that the component form is 10 negative 6. Okay, so the last thing then is to put all of these kind of pieces together. So we're going to try to do a handful of different things here. So it says a vector starts at point T, which is -1, 3, and ends at point A, which is 2, -5. We're going to label this vector T. One is to find the component form of this vector. Okay, well, we know to find component form, we are going to subtract our final minus our initial. That gives me 3, -8. Step 2 then says to rewrite it as a linear combination of vectors. Once again, really kind of scary wording. It just means to write in IJK notation. So I'm going to rewrite T as 3i minus 8j. That's all we're doing here is that rewrite. Number 3 then actually asks us to do some combinations, to do some math. So it says vector S is given as 2i minus j, and it wants us to find this. So it wants us to find 2 times t, well, t was 3i minus 8j, minus 3 times s, well, s is 2i minus j. So the first thing we're going to do is follow our order of operations. We're going to go ahead and multiply this in. We're going to multiply this in. And then just like we did with our normal math, or when we saw it earlier, we're going to keep our components together. So our i's and our j's stay together. When I do this, I get 6 minus 6, well, that's 0, I. And then -8 and 3, that's minus 5j. I can actually just leave this as minus 5j. If you wanted to put it back into component form, it would be 0, -5. So just showing you guys why I and J notation or unit vectors are useful. Once again, we can rewrite things as a linear combination, which really just means stick your x component with your I, put a plus or minus depending on the sign of your y component, and stick it with your j. And you can go back over this problem if you need to. But that is the end. That is showing you guys unit vectors and what we use them for.